We're solving systems of equations by substitution. If you don't know what that means, that's okay. What we're going to do is look at this line and this line, and here's the concept. They cross in some way, shape, or form, and we could graph it and be like, yep, look, there it is. But instead of graphing it, we are just going to use substitution. And the idea behind that is these two equations are talking about the same variables. There's y and y, there's x and x. So I noticed that on this purple equation that y is by itself, right? So if y is by itself on this purple equation, that means that y literally is negative 8x plus 2. And what we're going to do with that is we are going to substitute it in to the red equation for this y. So it'll look like this, 2x plus parentheses. Now normally it's just 2x plus y, right? And let's go ahead and throw the equals negative 10 for fun. But now it's negative 8x plus 2, okay? And what you're going to do next is simplify and solve for x. So this 2x stays the same. This is now negative 8x plus 2 equals negative 10. The x's combine to give us negative 6x. This plus 2 drops down. This negative 10 also just drops down, didn't change any. And now we're going to subtract 2 from both sides. We're going to divide by negative 6, and we get that x is 2. And you might think, okay, well, weren't we just messing with y? You're right, we were just messing with y. And what we're going to do now is we used the y to solve for x. So we're going to take the x and plug it right back in here. Or we could take it and plug it in right here. You have the choice to plug it into this green x or this yellow x right here. I'm going to choose the yellow x because this already has y by itself. So it would end up looking like this. Y equals negative 8 times 2 plus 2. And if you're like, why is that? Well, this is what it normally looks like, right? And notice that the x has been swapped for 2. Why 2? Because we found out that x was really 2, all right? And then we can simplify. This is y equals negative 16 plus 2. Y equals negative 14. So your job on number 1 was to describe this process. And a lot of you guys basically said, do this right here. And you're right. But this is the whole process. In fact, if you have no idea how to do solving systems of equations with substitution, then this is a good intro to how to do that, because you have 2 equations and one of them is set up perfectly ready to substitute. This next one might seem like it's not perfect and ready for substitution for one reason, and that this x is not by itself. So some of you guys did something pretty neat, and I'll share that in a second. But here's what I was kind of expecting you to do, is that you would have said, well, that x is not by itself. Let's divide everything by 5. And if you're like, why would you do that? Up here, the y was by itself, so we were able to use this, right? So down here, hey, the x, nothing is by itself, not here, not here. And so in order to do that, in order to get it by itself, you have to rearrange it. And this would now become x equals 1/5 y plus 1. And now you are ready to substitute. So you have that x is literally equal to 1/5 y plus 1. So you would take it and plug it into this one. If you plugged it into this one, you can't plug it into itself and expect it to work. You have to plug it into the other one, okay? Now, since I showed you how to do one already, and the goal here is really just to kind of help you to get started, I'm not going to be finishing every single problem these days. So Now let me tell you oh, I wasn't expecting that version that you guys did. So some of y'all were like, hey, listen, hang on, let me erase the giant arrow. Let's do this. Some of you guys said, hey, listen, I have 5x equals y plus 5. And you said, look, I have 5x here, and I have 5x here. So some of you smarty pants people out there were like, listen, this equals 5x. So what they did is they just substituted that. And so they got y plus 5 plus 3y equals 11, which is, like I just said, you took this and you put it there because 5x is this. Look, 5x is that right there. So I thought that was pretty smart. So let's check in on this one because it's very similar. And really all I'm going to say on this one is there's this equation, and there's just no way I'm going to be messing with this equation because I can't easily and quickly solve it for one of the variables. I mean, it's not going to be that big a deal, but the second equation is just set up to be so much more quickly solved for x. All I have to do is add 2y to both sides, and I am now ready to substitute this right here. Okay, so now we're actually doing some actual solving. So let's do one of these. You have y by itself, which means y equals negative 3x. So I'm going to take that negative 3x and I'm going to plug it in right there. And if you're thinking, well, wait, I saw that this y equaled this, and I plugged it in right here. Cool. It doesn't matter. As long as you make sure and do it, as long as you plug stuff in for whatever. So I'll leave this one blue. 6x minus 9 now equals negative 3x. So what I'm going to do is I'm going to subtract 6x. I get negative 9 equals negative 9x. And so we get that x equals 1. We can officially say that is our solution, part of our solution. And then what we can do now is take that 1 and plug it in for an x. You can either plug it in on the bottom one or the top one. In my opinion, the bottom one's faster, so I'm going to do the bottom one. So that is y equals negative 3x, or it's y equals negative 3 times 1, because we know that that x is really 1, and negative 3 times 1 is negative 3. So there is your answer for that one. All right, number 6, and I emphasize that because I'm skipping number 5. Number 6, solve the system by substitution. So I'm looking at this going, I cannot just immediately substitute, or can I? So again, like I said over here, some of you guys, I was like, dang, that's a smart move. I'm going to start looking for that. So there's 2 moves I'm going to look for. 1, I'm going to look for isolated variables. And I guess I could squeeze in a qualifier here. Or easily isolated variables. So, I mean, what I might have done for this one is I would have taken this one. In fact, I'm going to draw this line to kind of show you. This is what I would have done had I not seen something. I would have said, hey, let's divide by 8. And I would have been kind of annoyed because of that. We get x equals 5/8 y plus 3. And that doesn't make me super happy because I'm going to have to take 5/8 and plug it in here. I mean, the 8's going to cancel out when I do that, but I'm not real psyched about it. But, like I said, you guys are the smarty pantses, and I saw something you did. I'm going to see now if there are any just matching variables. And that comes with like a little asterisk. We'll draw a star next to it. So back over here, when we did this, this is 5x and this is 5x, and the reason that they're going to fit into this quote-unquote matching idea is that 5x is by itself. It is isolated, okay? So that I can immediately plug that in. So if we go over here, 8x is right here, and negative 8x is right here. This is isolated. So what I can do is I can take this whole thing and plug it in immediately right there. Hang on, that was a little misleading. I drew the arrow pointing to the x. I'm not going to plug it in for x. I'm going to like swap that whole thing, because look, there is that whole thing. So if you're like, I'm a little confused, then don't worry. Do it this way that I was just showing you, and then make sure that you take that, like I said, this 5/8 y and plug it in to x right there. In fact, why don't I just, because we're still kind of learning, why don't I do that? So we'll make this one green, and we'll do -9y equals 40 minus 8, and then in parentheses, I'm going to do 5/8 x plus, 5/8 y plus 3. Okay, let's just zoom over here and do this. The green part's not really going to change a whole lot. This is now -5y minus 24. We can add that 5y to get -4y. 40 minus 24 is 16, and we divide by -4 to get y equals -4. So you can see that that wasn't that bad. But like I said, I saw the y'all's Smarty Pants version, and so what I'd like to do is take this purple box right here. I don't know if you can see me tracing that. Take this purple box, plug it into that green box. So I'm going to get -9y equals 40 minus 5y plus 24. And if you're like, that seems tricky, check it out. 40 minus 5y minus 24. Check it out. 40 minus 5y minus 24. It was just kind of a shortcut. You know what? Shortcuts are okay, right? So we still have -9y equals 40 minus 5y, because this is, I'm subtracting that 5y, right? And I'm subtracting that 24. And so now that this and this are identical, I'm going to stop there, and we have that y is -4, so we put that here, -4, and to find x, we are going to plug this, let me change some colors here. We're going to plug this -4 either in here, or we could plug it in here. Either one is up to you. I'm going to pick this red route up here. I'll pick this red one because my x is kind of isolated. So it will look like this. 8x equals 5 times -4. Why -4? Because that was our y. And then plus 24. So we have 8x equals -20 plus 24. Well, that's 8x equals 4. So you divide by 8 and you get x equals 1/2. 1/2. There's your solution. So with this one, again, I'm kind of like opened my eyes. I don't know why I never really thought of it before. Again, I would normally have looked only for easily isolated variables, but now I'm going to be thinking about matching variables. So I'm going to do number 8, and I'm going to do it 2 different ways. I'm going to do it as like the easy isolated version, and I'm going to do the matching version. Just going to side by side it so you can kind of grow with me. Wouldn't that be nice? Okay, so easily isolated. I look at this one, and I'm like, okay, I guess that could be easily isolated. What I'm going to do is I'm going to add 0.5x. So I get -y equals, I'm just going to write 1/2 x because I like to, plus 7.5. And then I can just multiply everything by -1. I'm going to go back to the decimal because I guess I have more decimals, right? So this is now what y equals, and I can now take that and plug it in here, right? And I'm going to get 5x plus 2 parentheses -0.5x minus 0.7, nope, not 0.75, minus 7.5, and that's going to equal 9. Now we simplify to get 5x minus x, because 2 times 1/2 is 1. 2 times -7.5 is going to be -15 equals 9. These combine to be 4x. I'm going to add 15 to get 24, and x ends up being 6, because 24 divided by 4 is 6. And now I'm just going to take this 6 and plug it in either here or here. And I'm going to plug it into the top one just because it feels like it would be 1% easier as I'm looking at it. And by the way, we could have technically plugged it in here, right? But I just am conditioned to think to go back here. That's like my natural thought process. Feel free to experiment with the thought process because y'all, find interesting things that way. All right, so we get 30 plus 2y equals 9. 2y equals negative 21, right? Is that yep, it was 9. And 6 times 5 is 30. Okay. And then when we divide by 2, we get negative 21 over 2, which is negative 10 and a half. So now I said, hey, I'm going to do it the matching way. So I'm going to rewrite them over here just real quick. And now I have to make a decision. Which variable do I want to mess with? So to make the y's the same, let's say, or the x's, because it's your decision, we could multiply this bottom equation, the entire thing, by like negative 10. Maybe this is okay. Let's just do it. So then what we would get is 5x plus 10y equals 75, negative 75. And then I'm still not done, but the idea is that I was trying to get 5x and 5x, okay? And then what I'm going to do next is I'm actually going to isolate the 5x. I'm going to subtract 10y, and the negative 75 is already there. And now I can take this whole thing and plug it in, not just plug it in, but replace that whole thing, because that is 5y. So I would end up getting negative 10y minus 75 plus 2y equals 9. And then negative 10y and 2y is negative 8y. Add 75 to get 84. Divide by negative 8 and we get, check it out, negative 10 and a half. So it's the same thing, right? It's just kind of a different approach. Group spends $277.50 to rent a total of 15 tubes. How many of each type of tube does the group rent? Okay, so first things first is we're going to have this type of tube that we'll call X, we'll have that type of tube that we'll call Y. How do I determine that one is X, one is Y? Because the idea is that I'm going to get one type and then another type. And if I add up how many types of tubes I'm going to get, it will equal 15 because they got 15, right? So this one is just about tubes. And then the next one's going to be about money, okay? So I can actually immediately go over here and do $277.50. And then what I'm going to do here is now it's going to be $12.50x plus 20y. Check that out. Now we've got this set up, and this is why I did this problem. Is just, I don't know if you're out there struggling with setting up word problems or not, but by the way, this one's about the money. So that's a dollar amount, dollar amount, dollar amount, right? Number of tubes, number of tubes, number of tubes. Anytime you're kind of doing math like this, word problems like this, I should say, try and make the like things go together. I think you can solve it from there. Last but not least, this one requires you to know, at least I think it requires you to know that quadrilaterals, basically four-sided polygons, when you add up this angle plus this angle plus this angle plus this angle, if you add them all up, they will equal 360. And if you're thinking, man, how would I know that? I know that is a little bit of a tricky one, but if you had a square, they're all 90, and guess what? 90, 90, 90, 90 is 360. If you have a rectangle, same thing, okay? This is a pentagon. No, it's not. This is a trapezoid, and it still works. So we have this info. We have 2x plus x is 3x. We have y plus 10 plus y. That's 2y plus 10 equals 360. We can solve this a little bit to get that 3x plus 2y equals 350. And then when we take this info up here, negative 2x plus y equals negative 35. Well, why don't we solve this to be y equals 2x minus 35. And then all of a sudden, look, we can take this piece, plug it into this purple piece, and we can solve from there. So we have that, plug it in there, 3x plus 2 times 2x minus 35, and we're going to get 3x plus 4x minus 70 equals 350. 7x equals, let's see, 420, and when you divide by that, you get 60. Now you plug that back in. So how about plugging it in right here? So if y equals 2 times 60, not equals, minus 35. So that's y equals 120 minus 35. Y equals, let's see, 85. That sounds about right to me. So we said 60 and 85, 60, 85.